In this next module, we are going to install this package, Mongoose. This is an object document mapper, and this is going to help us to connect, save our models to the database. So first off, we're going to create a models folder, and this is going to hold our watch list item. We're going to name this watch item.js, and we need to pull in the Mongoose module here with require. Once we have the Mongoose module, we can create our schema. Remember, MongoDB is schema-less, but with Mongoose, we need to create a schema. We'll rename this watch item. And remember, this is the blueprint for the model for watch list. So we're going to define the properties on this object. The symbol is going to be a string, and we're simply going to need a date created as a date timestamp. We can expand on this model as we build this application out. We can rename watch item schema, and now is where we build out our model. So we are going to use mongoose.model. We're going to give it a name of watch item, and we're going to plug in the schema that we just created. And this kind of tells Mongoose what type of model to create. And when we create this, we're going to export it out so we can reuse it using module exports. So then we have a model that can be reused throughout our application. And on that model is all of the CRUD operations for saving, reading, updating, and delete. Now we can go back into our watch list module, and we can get rid eventually of this temporary cache database because we're going to be interacting with the real database now. So we're going to have persistence. We would like to bring in that watch item model. So we're going to require that in. It is a node module, so we can import it with require. We need to make sure we're going to the models folder though, /models/watch item. Make sure we're navigating correctly. If we look at the documentation here, you'll see on the model there is a save method, just .save. Make sure we're on the right version of Mongoose here. And you can see on the right side, there's so many different types of helper methods for saving, finding by one, and deleting. So they're compound methods, and there's a lot of different ones. But for our use case, we just need to save. So we can use this example here to kind of guide us. Remember, we're connecting to our local host here for MongoDB is running in the background. We've already created a crypto coin tracker. So Mongoose will go ahead and create this connection and create the database schema for us. Even though we don't have any records, Mongoose has taken care of this as long as there are a connection to the Mongo database, which is great. It auto sets up for us. So going back to our add item function or method, we want to then unhook the cached temporary data here, and we want to persist to that underlying MongoDB database. So using our model, watch item, now we have the CRUD operations on them so that we can do a .save against it. First, we need to define the model we would like to save. So we create a new instance of the model watch item. And this is where we pass in the symbol that has come from our API. So we're going to pass in the symbol, and then the date time could be the current timestamp, created as the current date. So date.datetime.now. Once we define this model and everything rebuilds, we need to create it. So we can use the watch item module. We need to trigger it. And how we're going to trigger it is through our API. We can get rid of this temporary cache data now. We don't need it. And we need to do the same for the get items and the remove items as well. So very simply, now that we have the model defined, for retrieving is very simple here. We can just do a .find. So we made a mistake here. We need to actually pull out the watch item model because that's what we named it, watch item model. So we got to make sure that we're actually pulling in the correct model. So watch item module from. So here we just need to update this. That's why the IntelliSense was not actually seeing the .save method because we were using an incorrect name. So if we need to make sure that we're actually passing out the proper model here, watch item. And we're going to use .filter here to. It's crashing here because we're trying to use a dot filter instead of the dot find. And we may need to adjust this a little bit here to pass out the proper watch item so it matches what we named it. So going back to Postman, we're going to trigger this. We're going to try to post, add it to be saved, that item, go back to our database. We're seeing that there is one document now, so things are working. And we're triggering it through the Postman client. So we can see here navigating our collection. We can do different views here, but it is working, it's connected, and we have that one symbol that is saved. And we can go ahead now and change this and add another one, BDC. So now we're saving directly to the MongoDB. We'll add a couple of these. Ethereum. Refresh our database back in MongoDB Compass, and you'll see now we should have 3 records, and we click refresh. We have 3 documents. We may need to click refresh here. So this is persisting. This is really good. Mongoose is working for us. Now we're going to try to do the GET request here. So I think there's an error here with the GET request because I think we have the wrong, we're using filter instead of find, because Mongoose for retrieval is going to be using the find operation. So I think we need to change this. So we'll try the dot find. We're going to pass in a 0. We're going to pass in a null object or an empty object. Normally in that object is where the conditions go, like pass me all BTC or pass me all different crypto values. That's where you would traditionally put the conditions in there. So now that we're actually calling into it, we need to convert this to async await to allow the server to have time to retrieve from the database. Because if we synchronously try to call from the database, the response may skip ahead. So we may need to change this to async await. Easy enough, we can mark the function as async. And then we mark this method as awaited because it's already returning a promise here. So back in our endpoints where we're calling this from Express, we may need to make a change as well here. So now back in our GET request here, you can see while we're fetching, we may need to await this now. We need to wait for the database to finish before it responds. So let's make a change here and see if this works. We'll trigger it again. And now you see the data has come back now because we gave time to the database to query. So now we're getting our full payload. We have the GET request working through the database and returning to Express. And we also have the POST request working. So this is looking good. We may now need to look at how to remove or how to delete. So we can take a look at the documentation here for Mongoose API, and we're going to look up delete one. And like I said before, they have many types of different delete methods here, delete many, delete one. So we can go back to our module here, and now we can fully get rid of this cache list. We don't need to filter out anymore because we're going to be fetching the real list. We can get rid of that, and there's going to be no more filtering. We're just going to delete directly from our collection using the watch item model. We may need to mark this as async as well, but we have that watch item, and we don't need to return a value here because we're deleting from the database. So we have the watch item module, and we're going to delete one. We will give it some criteria here. So this is where you can plug in a lookup on the field. So this would be the where clause, delete where symbol is equal to symbol. We can do the same thing for find as well. Find where symbol equals to the symbol if we wanted to. If we wanted to get a singular item, we could do that as well. Since we made that asynchronous, we may need to go to our delete method in here. Actually, this is a really good time to create a delete method that we were missing before. So we can actually add our second verb to expand our API a little bit here. Express app instance.delete to handle that delete method. It's on the watch list route. The same request and response is going to be returned. We can console log to the server that it has been called to test it out initially. We actually had them in the incorrect order. Request needs to be the first parameter, response the second. So now we're going to send back the response. Server received the data. And we quickly want to do this again to test in our Postman that the delete verb is now set up. We can go now and trigger that action here. Create a new tab, and now we're going to use the delete action here on the same endpoint. Once we send that request, we see it's wired up. So we're in a good place here. Now we can finish off, call into the module for our remove item. We're going to mark this as a sync, and we're going to await the watchlist module dot remove item. We need to make sure that we're pulling out the symbol from the query. So we're going to pull out the symbol in the same way we did for posting. So using destructuring on that request.query object, we're going to pull out that symbol and we're going to pass that symbol through to our remove item module. And in that function, we've already set that up to delete one. So now we can try this out. Back in Postman, we can take a look at the post and how we did it. So we added a param and we added the symbol key, and the value is the actual cryptocurrency symbol. So let's try this out. We'll fetch quickly to see we have 3 items. We're going to try to remove one. The server responded, okay, successful. Go back to our fetch. We have 2 items. This is working already. This is looking good. That data received from the server, we refresh, ADA Cordana is left. And if we delete that one as well. So we have persistence working here. And this is part of our application that's looking really good now. We can build this, we can build out our watch list item and from the front end, and we can integrate. We don't really need to send back anything if we didn't want to clean that up. But the module is looking good. It's all functional. The Mongoose connection is working well. We can add some error handling here if we wanted to. So on the server, we may not want to send back a server error to the caller. So we can protect those errors by wrapping everything into a try catch. Because we're working with the database, there could be some issue with the connection. And if we were to catch it, at least we could log to the console that there was a problem with the operation. We could even go as far as to send back a friendly message, or we could actually, in more advanced implementations, play with the status code and return back a 504 or something like that to the calling API caller. But for right now, we're just going to wrap everything in a try catch. This type of error handling to all of these methods here. So we kind of get that skeleton of it, and then we put our working code in the middle of it. So basically everything is nicely kind of protected. We'll mark this add item as an async await just to be consistent. And we can apply the same strategy here for removing the watch list item. So just wrap everything in a nice try catch. Because we're persisting and making changes to the database with the adding and removing, there's more chance of error than just scanning the database. We can still wrap our get items here in the same try catch. Because if we certainly make a scan against the database and the connection is not there, we don't want the user to get that output from Mongoose that the MongoDB client is down. We would rather have the UI or the client receiving a nice error, like there was a problem, there's a internal problem, or there was a problem with the application, please refresh, or something like that. We don't need to see Mongo driver details in the front end. It makes for a bad user experience. So now all of our CRUD operations to the database are protected. And in later implementations, we can add a nice error message here or handler that gets fired from the server, and the UI maybe shows a nice dialogue or some kind of toaster message to let us know. So we have everything wired up. It's looking really good. Now we can further integrate with the UI in the next module.